Good morning, guys. Today I want to go over the exponential word problems in the review. So just as a quick reminder, when we did exponential word problems, we used this formula a lot. It was y equals a times b raised to the x. The a was the initial value. The b was the multiplier to get to the next term, and then x and y were the variables. The x was in the exponent position. Okay, number 6. They're telling us that the bacteria has an initial amount of 100. So now I'm going to substitute that value for A. They say that the bacteria triples every day, so they're giving you the multiplier, which is the B. So this is what the equation would be for finding the number of bacteria for day X. So if you want to know what it is on day 10, then we'll just simply do 100 times b, which is 100 times 3 raised to the power of 10. Then on your calculator or on your Google calculator, 100 times 3 raised to the 10. Okay, notice that this calculator and scientific calculators can do order of operations, so I can type it all in one step. Commas in. So the number of bacteria after 10 days looks like it'll be 5,904,900 bacteria. And as we all know, exponential growth starts off very slow, but as it goes on, the numbers get very, very large quickly. Okay, similar. Number 7 and 8 are growth and decay, exponential growth and decay, but they give the multiplier as a percentage rate of growth or rate of decay. So all I'm going to do is I'm going to switch that multiplier as 1 plus the growth rate, or if it's a decay problem, 1 minus the growth rate. Okay? If it's growing, the multiplier should end up being more than 1, and if it's decaying, the multiplier should end up being a number less than 1, between 0 and 1. Okay, let's take a look at number 7. The value of the TV is initially 4,500. That's expensive TV, I think. All right. Times, this time the multiplier would have to be less than 1 because the decay rate, they say, is 15%. So I change that to a decimal. I do 1 minus that 0.15. And then I raise that to the number of days, because that was a daily decay rate. I'm sorry, a yearly. What is that one? Let me see. Nope, that's a yearly. Yeah, sorry. The TV would not decay that much in one day. So it starts off with 4,500, decays 15%. So in other words, it keeps 85% of its value. So that's why the value of it's going to decrease each year, because this is less than 1. All right, so this represents the equation to find the value on year. Sorry, I labeled this wrong. It's kind of throwing me off. On year X. So if you want to know what the value is going to be at year 10, just simply do what we did in the last problem, now that we did 1 minus r. 4,500 times 0.85 raised to the 10th year, 10th power. 4,500 times 0.85. Because I already subtracted, I don't need the parentheses. But if you're going to do this in this step, make sure that you're using the parentheses. Raised to the 10th year. Okay, I'm hoping for something that is less than 4,500 because it's decaying in value each year. So on year 10, the TV should be worth $885.93 on year 10. Okay. Similarly, we have a growth problem, and it's given as a rate, not as a multiplier. So the initial value of this diamond is $25,000. It increases by 9% each year. So it keeps its initial 100% of its value, plus I change that 9% to a decimal, and I raise that to the number of years that is being invested. Okay, let me clean this up a little bit so I can see what the multiplier is. If it's increasing by 9% each year, the multiplier, that B value, is actually 1.09. So each year I'm multiplying by this to get to its next year amount. Put an X in there for now. So we have just the general equation for finding the value of the diamond at year X. And then they ask you for year 20. So I very simply just plug in the value for time in for that exponent, 1.09. And then in the exponent, I plug in the 20. 25,000 times 1.09. I could type it in with the parentheses, or I can type it in as I'm doing it on the calculator, just multiplying. Raised to the 20th year. All right, and as I suspected, it is increasing in value. It is now worth a lot more. 20 years is a long time. So it did increase substantially. $140,110. 20, I'll round down because it didn't quite get there. 26 cents on year 20, if everything goes as far as expected. All right, that reviews a little bit of exponential growth. The key parts are the A is the initial value, the B is the multiplier, and then X is usually the time that's plugged in, and that will be, could be daily, it could be yearly, it could be number of days, it could be number of years, depending upon if your rate was years or days or whatever the time period. Okay. If it's given as a percentage increase or decrease, make sure you change that percentage to a decimal and then add that onto 1 or subtract that onto 1, like so. All right, guys, final full week. Have a nice day.